Hey everyone, welcome once again to yet another live stream on Hack This Fall Season 2.0 YouTube channel. And today we are again with yet another amazing and super exciting live stream over here. So let me know in the chat how many of you are, you know, looking forward to this session as well. I have been waiting for this particular session. Do you know why? Can you guess the reason why the excitement was building up again and again? And we all were waiting for this particular live stream. We had been conversing about the same on our Discord, in our close communication groups and different channels all together. So without wasting much of your time and not teasing you a lot, let me quickly announce that Agoric is our title sponsor, and we do have an amazing lineup of speakers who are going to take us through everything around decentralized finance, blockchain, building NFT applications, and more around the same as well. So tighten your seatbelts and get hyped around the same, because we are definitely going to be on roller coaster of these amazing insights which Agoric is going to share with us in this live stream. So I already seeing the chat. I'm already seeing so much of excitement. Let's bring some of your favorite emojis in the chat once again to feel that energy in the chat and feel that excitement once again. So like time you do, bring some of your favorite emojis, and I'll be on the lookout for each and everything. Meanwhile, while you do that, let me quickly introduce what Hack This Fall is all about. So, everyone who is joining in for the very first time, Hack This Fall is a virtual hackathon, a 48 hours virtual hackathon that we are going to host on 22nd to 24th of October. So, make sure you have registered yourself going to the link hackthisfall.davepost.com. All the required links are there in the description. Make sure you check them out as well. So, that was pretty much from my end. I see already a lot of excitement in the chat, favorite emojis, fire emojis, hearts, poppers, party emojis, and whatnot. Thanks a lot for adding so much energy in the chat. Really appreciate that. Cool. So enough from my end. Let me quickly invite first speaker for this particular stream who will be taking us through introduction to decentralized finance. And here we have Roland joining us from Agoric. Hi there. How's it going?
Good. How are you, Siddharth?
I'm doing good and quite looking forward to this stream as well.
Great. Well, so thanks so much for having me on. As you mentioned, there are a few speakers coming from Agoric this evening for you guys, this morning for us. And I'm excited to take you through an introduction to decentralized finance. So if you don't mind bringing my slides up, actually, yes, thank you. So I'm the product manager at Agoric, so we have a few speakers coming online. My goal for this talk is really to give an introduction to the market activity that's happening in the crypto space, specifically decentralized finance, but also giving a little teaser on NFTs as well. So, I want to make sure that for those of you, I know there's a lot of people potentially coming to this hackathon that don't have a lot of background in crypto. So really the goal for this is to be a high level overview of what is going on in the market, what is interesting about some of it, and then to do a deep enough dive that you understand some of the mechanisms of how these protocols are getting built, and then to give you a little bit of an overview of what's happening in NFTs. And so then after I speak, we'll have two great speakers coming on. Both Dean and Kate will take a step back. Dean will give you an overview of what that means to build in Agoric, and we have a build challenge coming up for Hack this fall. So really want to make sure that you guys are ready to take that on. And he'll do a great overview of that and smart contracts. And then Kate is going to do a Code with Us session on NFT applications. And so that's in part why I added NFTs to my talk here, just to give a little bit of a taste there. So I'm going to do my best to take questions as they come, but I also will have a little bit of time at the end. Hopefully, I've got a lot of content to get through. I'll try to leave a few minutes at the end to take questions on anything that I've talked about. So with that, let's actually get rolling. So I always like to start with just a definition of what decentralized finance really is. And this is just mine. I mean, it's a new space, it's evolving. People have their own views on what these things are. But to me, decentralized finance protocols are permanently deployed, credibly neutral, non-custodial applications, which allow users to permissionlessly exchange assets or risk. And I'm going to go through each of those. So permanently deployed means that as long as the blockchain is running that you have deployed to, your application will continue running. And as long as you've set up the economics in a way that will not cause your application to shut down. It will run indefinitely. And so that does change the way you think about how you build things, right? You're not necessarily hosting it yourself, the chain is hosting it. Credibly neutral means that really the goal here is that instead of having a middleman like a bank sitting between lending parties, for example, it's really just code. And you want your protocol or your product to be viewed by all the participants as being fair to all of them, and to have rules that are sort of clearly enforced. And that's really kind of the big driver here of what's different in DeFi. Non-custodial is a really important piece as well, which means that when users come to your application to interact with it, they don't have to send their money to you first for you to do things. And at least in the American banking system, when I am trying to interact with financial services, I have an E-Trade account, for example. I have to send money to E-Trade, wait for a week for it to clear, and then I can do the things that E-Trade allows me to do within their own application, and buy the funds that they allow and all that stuff. If I want to do something different, I need to go through a long process to get that money back and then send it somewhere else. DeFi is different. In DeFi, the user is coming to the application and and controlling their own funds and connecting to the application, which allows them to do something. If they want to go do something else, they really just disconnect or ask for their money back, and it comes back in a minute and they go somewhere else. So non-custodial means that this space is extremely competitive, it moves quickly, and users have much more control than they do otherwise. And the last thing is permissionlessly. So really the goal here with decentralized finance applications is to make sure that your users can come and interact with your protocol without having to ask permission. As long as they meet the rules of the protocol itself, they can come interact. All right, so let's take a look at how DeFi has grown. So this is a slide from DBank. Depending on where you get the data from, I've seen estimates as high as 200 billion for overall DeFi. But really, the idea here is really it's just grown significantly in the last year, right? I remember seeing slides in early 2020 around DeFi hitting 500 million or DeFi approaching $1 billion, and that seemed like such a big deal to me. And now we're sort of entering the hundreds of billions of dollars locked phase, and it's starting to really change the dynamics of what's happening in the space. And an important part of this chart here also is that there's really just two primary applications that have driven this thus far, and that is decentralized exchanges, and this groups automated market makers separately, but really those things are kind of the same: decentralized exchanges and automated market makers, and then also lending protocols. And in this talk specifically, I'm going to go through those two types of protocols. And I know that I've only got half an hour, which is not nearly enough time to teach this from scratch, but I'm going to do what I can here. So let's keep moving. So I mentioned I'll talk through automated market makers, I'll talk through lending protocols, and then I'm going to give you just a quick taste of NFTs and my own sort of thoughts about where that market is going, what's interesting about it, what has happened so far. And then, as I mentioned, I'll give some closing thoughts and leave a little bit of time for questions. All right. So let's start with automated market makers. And I've found that the most useful way to think about automated market makers is to compare them to what you might be used to when you are trading a stock or trading any other kind of financial asset, and that is an order book. And so I've got two screenshots here of actual UX. One is an order book from FTX, and the other is an automated market maker, the primary one in Ethereum, which is Uniswap. You can tell there's sort of immediate differences in terms of the simplicity. So user coming to the system, what do they see for the first time and how do they interact with it? That plays in, but I want to go through some of the dynamics of what it means to transact on an order book. So for those of you that haven't done this before, an order book is just a series of buy requests. So you see these in green on the left, and sell requests. You see these in red on the right. And the sell requests are by people that actually own the asset. The buy requests are by people that own the base asset and want to trade it for the other asset. So the way these are ordered are such that there is a top price of a bid, which is the highest price that anybody that wants to buy is currently willing to buy at, which is 3,561.4 as of the time I took the screenshot. And then you've got the lowest price that anybody is willing to sell for, 3,561.5. So you can see it's a little higher. All an order book is doing is ordering these lowest to highest, and then if any of them overlap, then the central exchange will match the order, which means that anybody that's buying has a seller correlated with them. So every transaction that happens has one buyer and one seller. On an automated market maker, really what you're doing is you're really just swapping one token for another. And as a user, I come to the system and I say, I want to sell 1 ETH, and then it's going to give me a price for that ETH. And we'll talk about how that price, where that price comes from and why. But as a user experience, it's significantly easier. You can see actually that these prices are very, very similar. And I took these screenshots sort of roughly around the same time. That's not an accident. All right, so in an automated market maker, instead of the token seller and the token buyer interacting with each other, they're both interacting with a liquidity pool, which is provided by an external group of users, which are called liquidity providers, or essentially the market makers. And I'll go through some of the dynamics of how that works. All right. So this is a walkthrough of a basic walkthrough of an automated market maker through a few different user functions. And the way this particular automated market maker that I've used here is Uniswap, and this is their V2 model. So to start with, we've got 3 groups here. We've got liquidity providers, we've got the pool itself, and then we've got one trader. And you could imagine different traders, but let's just say that there's one for now. There's a pool that already exists, which has 100 ETH in it and 100,000 USDC. And USDC is just a representation of a dollar, effectively. So in this particular scenario, we're sort of assuming that the price of ETH is $1,000. And you'll notice that the dollar amount of ETH and the dollar amount of USDC are equivalent. So 100 times 1,000 is 100,000, and there's 100,000 USDC. That's an important piece. Whenever, at any point when you are adding or removing liquidity from a liquidity pool, you have to do it in equal parts of the 2 tokens that you're adding. And the idea of the pool is that at all times, it has 2 tokens, and those tokens are, by definition, at equal values. Okay. So let's go through what happens as transactions occur and things change in this pool. So in the first step, we have a liquidity provider that's adding 1 ETH and 1,000 USDC. And again, remember, they have to contribute in the exact same proportion of that exists in the pool right now. So they're doing that. So it's 100 to 100,000. They're doing 1 to 1,000. And now the pool has 101 ETH and 101,000 USDC. Now, let's say a trader comes in and says, I want to buy 5 ETH for USDC. And they don't necessarily know what price that they're going to get for that ETH. They just know they want to buy 5 and they want to see what the price is. So how does the pool know what price to give them? So remember, the pool is the only thing determining the price. The pool doesn't know anything about the external world. All it knows is it's got a certain amount of assets, and then it's got a formula to transform one asset to the other. And the formula is called an XYK curve. So X time the ETH asset times the USDC asset equals this K constant here. And you can see I've got K listed underneath the pool. And K is constant for any trade. The only time K can go up or down is when liquidity is added or removed. So you see that as liquidity got added here, K moved up, which is just 101 times 101,000. Again, it's just a constant. It doesn't have any market significance other than that. But then when a trade happens, what the pool says is this buyer wants to have 5 ETH. So it means I have to give them 5 ETH. So the new ETH in the pool is going to be 96. 101 minus 5 is 96. And the amount of USDC that I now need to have in this pool needs to be 106,260. And the reason for that is K, 10,201,000 divided by 96. That's all the pool is doing. So it says, in order to give you 5 ETH, I need to have this amount of USDC in me when the transaction is done. And that means that user has to put in a certain amount of USDC to get there. In this case, I think 5,260. All right, I'm gonna pause for 1 second. Any any questions on that specifically? I see some general questions in coming in, which I can take at the end here. Okay. And you'll notice that the price of ETH was assumed to be $1,000 here. And really what that means is 1,000 USDC per ETH. But after the trade, the price of ETH has gone up. And that is a core dynamic of an automated market maker is there was demand for ETH. Somebody went to buy ETH, and that caused the price of ETH to increase. And you saw all it was doing was just simple division to say, I've got a constant K. I know how much ETH I have to give. And so this is how much USDC I want. And therefore, the price, the relative ratio of USDC to ETH in the pool has changed, and the price is different. And now this liquidity provider says, okay, actually, I want my liquidity back. They had 0.99% of the pool before. They currently still own 0.99% of the pool. And when they pull their liquidity back, they're pulling 0.95 ETH and 1,052 USDC. So the actual proportions are different now because the price is different. And what the liquidity provider, in this example, I'm only showing one trade. Hypothetically, there could be thousands or millions of trades that occur prior to the liquidity provider pulling their liquidity out. What they are earning is fees on each of those trades. So there are fees that the traders pay, which overall, over time, actually increases the K, increases the total amount in the pool. And when the liquidity provider pulls their liquidity out, they have earned some fees. So that's all an automated market maker is. And this is specific to an XYK automated market maker. But when you look at the core products in the market, that's really how most of them are operating. All right, let's keep moving. And I know if people have questions later, I'm happy to take them here. And so I wanted to kind of take a look at the actual market dynamics of the DEXs themselves. So, and again, I'm pulling all this data from the same source, but there's a few core DEXs: Curve, Uniswap, SushiSwap. Uniswap has a different version, which is a truly different product. And then Bancor, and you start to get to a bunch of other smaller ones. These are all very ETH focused. There are large automated market makers on other chains. Agoric is going to have our own automated market maker. But you can see that the value of, and really this is liquidity providers' value. This is value locked in the automated market maker, has just shot up since July of 2020. And a lot of that is Uniswap and SushiSwap. You see Uniswap actually drop for technical reasons, but that's in part because Uniswap v3 launched, which is much more capital efficient. We don't need to go into it. One interesting piece here is you see a giant dip in Uniswap around, I think this was sort of November-ish 2020, and that was when SushiSwap launched. And there was a really great story about how that launch occurred, which I won't go into now because we don't have time, but it sort of shows the competitive nature of the space. All right, let's keep rolling here. To sort of summarize AMM use cases, so I went through a toy example of how an AMM works, but why do they exist and why do people use them? For new projects that are launching, in the past, in order to get a market for a token, it meant trying to get Coinbase to list you, trying to get Binance to list you, trying to get some centralized exchange to list you, which may cost upwards of $1 million or more, right? It's not a cheap proposition to get the exchange to do it, and they have limited resources and limited tokens that they can offer. With an AMM, new pools can get added by anyone, and it means that new projects can raise money and build a market for their token very quickly. For investors, it means that they can go to a straightforward UI like Uniswap or any of the other automated market makers and just buy and sell in a very quick manner, and they never have to give up custody of their assets. So remember, we talked about this before, where I don't actually have to send my money to Coinbase and wait 3 days for it to clear and then request it back and wait, have a review and all that stuff. I just come, connect my wallet, make a trade, and leave. And it's a 5-minute operation or less. And then for holders of the tokens, they can become liquidity providers and earn fees on top of traders which want to trade back and forth between those different tokens. So it's another way to earn a return on the assets that you have. All right. Okay, I don't see a ton of questions, but I see some excitement about this, and I agree. I mean, to me, the automated market maker was such an important innovation in crypto. And I'm going to go much more quickly because I've only got a few minutes left and I've got a lot of stuff to go through. So I want to talk about over collateralized lending. So let's see, what is the use case for a user coming and taking a crypto loan? Let's walk through 4 steps. I begin with some crypto asset. So let's say I have 10 ETH and I supply that 10 ETH as collateral to a lending protocol. And that gives me a $34,000 deposit balance for that 10 ETH. Because as of today, I think ETH is roughly $3,400. I haven't actually checked. Based on the contract settings, so specific to the loan protocol itself, let's say hypothetically that the user is allowed an 80% borrow limit on their ETH balance, which means that I'm allowed to borrow up to $27,200 against my $34,000. I use that to borrow 20,000 USDC, which is roughly $20,000. And at that point, I have that USDC and I can go use it however I want. My ETH remains locked up in that lending protocol until I start paying back my loan. And I can borrow additional USDC because I didn't quite hit my limit before. Or I can remove some of my ETH because again, I didn't need the full limit. But the only thing I need to make sure that I'm doing is making sure that my borrow amount is not greater than the 80% of the supply amount. And by reducing my borrow, I allow additional ETH to be taken back out, which basically means if I pay back my loan, I can take all of my ETH back, right? So I'm going to pause for a second. Any questions on that flow? I think the primary question that should come up is what happens if the price of ETH drops, right? So my borrow limit was based on ETH being at $3,400. I've got 10 ETH, which I'm apparently a rich man. But say ETH drops to $2,000, right, from 3,400, which we all know it can do. It can do that over the course of a week or over the course of an hour. What happens to me, right? I've borrowed against something that no longer has the value it used to have. The loan protocol has a mechanism to deal with this, which is called liquidation. So the protocol itself maintains its own solvency. And the way it does that is it knows the price of ETH based on an external source, and that's called an oracle. I won't go into oracle details. There's a whole bunch of literature and different products doing different oracles in different ways. It's actually a hard problem. But let's assume for the moment that the protocol knows the correct external price of ETH. As the price of ETH drops, if it goes down below that liquidation value, and that liquidation value is sort of representing the 80% borrow limit versus the amount I have, then the protocol actually can take control of the ETH and sell it on the open market to nullify my debt. So it has given the limit, the borrow away. As a user, as a borrower, the protocol doesn't know who I am, can't force me to pay it back, can't force me to do anything, doesn't know who I am, but it does know that it has my collateral and it can sell that collateral if it needs to. And that's how it stays whole. So again, it's just rules built in software that everyone can see and can see how they operate and can test that allow borrowers to deposit assets and earn a return, allow savers to deposit assets and earn a return, and allow borrowers to come in and borrow crypto capital. All right, I'm gonna skip through this. So borrowing use cases, why do people do it? You can get assets out without having to sell your crypto. You can use it to lever up, which is sometimes a good thing. It should be done in moderation. You can use it to short. So you actually borrow a crypto asset and sell it with the idea that it will drop, you buy it back lower and return. And so that's the mechanics of how shorting works. And then there are also very specific crypto use cases that I'm not going to go into. All right, so that's the DeFi section. I've only got 4 minutes left here. I do want to do a quick what the hell's an NFT overview for those of you that have probably heard about it, maybe haven't dug in deeply enough to really sort of see what's going on. There's a lot of market activity happening. Some of it will remain 6 months from now. Some of it probably won't. But it's good to know and to understand. And I'll talk through a few of the trends here. So in my view, non-fungible tokens are the digital representation of nearly anything that isn't money, because most things in this world are fungible. Even if I'm buying bananas, you could think of bananas being, I don't really care which one I get, but I do, right? Like some of them are rotted, some of them aren't ripe. I'm buying a specific banana because I care about which one I get, so that makes it non-fungible. As one sort of very developer-focused way to think about this is the difference between fungible and non-fungible. If my address is this gibberish here, and I want to say I have 3 of something, if it's fungible, it can be represented this way, right? This is my address, my balance is 3, and then some absurd number of decimal points later, still zeros. If it's non-fungible, it means that there are 3 specific token IDs, and my address is associated with each one. And each one may evolve. It may have data associated with it that changes over time, depending on the use case, but I own 3 of them. So that's one way to break it down, right? For fungible things, it's really just a balance that can change. For non-fungible, I actually own specific things. So a lot of what's gone on in the non-fungible NFT space has really been around sort of basic artwork. And you may or may not like the art. I think that's ultimately not the point. The point is that what people are doing with this are building communities. So this is CryptoPunks here, which are the sort of canonical non-fungible token right now. Bored Ape Yacht Club, same thing, where 10,000 of these exist, and they're all a little bit different, and there are a bunch of owners of them. And really what they've done is built a community, right? So somebody here decided to put their CryptoPunk up in Times Square, right? That kind of activity and excitement around a community of people that all own similar things is really what is driving the value. And if you think about it, that's really what the art market always has been, right? I may or may not like Picasso, but the reality is a whole bunch of people think that Picasso is a really important artist to own. And because of that, the paintings are valuable. And it's no different here. If you think that CryptoPunks are still going to be interesting 6 years from now, then it's worth owning them. If you don't, it's probably not. There's also a lot of examples happening in gaming, right? You might buy a token that represents some important in-game asset that can be used once the game launches. And you're seeing a few examples of games that are pre-selling NFTs to fund the actual game development, which is a really interesting trend. I've sort of enjoyed seeing that these game assets can be sold on an exchange that is not controlled by the game itself, right? This is actually an exchange that has multiple different UIs. People can access it from tons of different places, all accessing the same order book. Don't have time to go into that, but that's a trend that I've really, I think is driving this as well. Slide here is really just to show that there's a lot of activity in this space and a lot still happening. So gaming, virtual worlds, sports, financial, music, again, it's the digital representation of anything that isn't money. So it just continue to explode. And really, in my view, it's a green field, right? You have a lot of opportunity here. There's a lot of places to explore, but you do need to kind of understand the dynamics of the market and what you're doing. So I'm going to end here with some thoughts on what it means to be a builder in this space. And hopefully this has come out as part during this talk, but it's hyper competitive. A product with a 1% better return can win 100% of the market because users aren't locked in anywhere. They can come to the next best product. And that's so interesting for an open source software dynamic where you can build off of everybody else. You can call everybody else's functions. If you have a better idea, you can have a giant product quickly. And the marketing effort is far different than you would see in like enterprise SaaS. You have to think about the community. So, and moving to the next bullet here, building a product means progressive decentralization. You're exiting to the community. Community building, Discord, Twitter, all that stuff is critical to your success at all stages. You need to make sure that people are on board, people like what you're doing, they're involved, it's open source, and there's additional contributors. That ends up being a core part of your product. For DeFi, your token is also part of your product. So you have to make sure that it has a use case, and you may find that you actually don't need a token. Uniswap operated just fine without a token for several years, and probably still could if competition didn't come into the space. And then for NFTs, your product really isn't the artwork or whatever you're actually launching. It's access to something. It's access to a creator and their works over time, right? If you you own NFTs by a particular artist, the hope is that those NFTs give you some access to future works by that artist. And that's how you want to think about things. It's part of a social club, or it's part of access to a game or in-game assets. It's really about building the community and having something for a group of people to rally around. So with that, I know I'm a little bit over time, so I'm gonna wait 30 seconds here for questions, but I know Dean is ready to come on and talk on Agoric specifically and go into a little bit more detail on smart contracts. So if you do have any questions, feel free to post them now. Otherwise, yeah, Kesadov.
Hey, Olin, thanks a lot for that wonderful session. And I had definitely seen the excitement, like you have already, mentioned that while you were speaking. So that was pretty amazing as well. So feel free to ask any questions you might have around DeFi or anything else as well. Roland would be more than happy to answer all of those right now. I see one over here. Uh, okay, I missed it. It just scrolled up. Let me quickly check back. Cool. No, I might have,
All right.
checked something else. But any questions, if you have, feel free to drop those questions down and would be more than happy to, pick them up.
Yep, and also feel free to reach out to me over Twitter. Come to the Agoric Discord and find me there if you want. Happy to stay engaged. And we have a build challenge for Hack this fall, which will be NFT focused. So really, really excited to see what you guys can come up with there.
Yeah, definitely. And stay tuned for that particular challenge announcement. We are going to do that super soon, and I'm sure you all are definitely going to love about the same as well. I see one question over here, a very beginner-friendly question.
Yeah.
As a beginner, what would you suggest to someone who's just getting started with blockchain?
Yeah, and so I guess what I would say is hopefully Dean's presentation will speak to that a little bit, and joining a hackathon like this one and working with us in particular on our build challenge is probably a great way to do it. There's a lot. The space can be overwhelming as somebody that's sort of coming in for the first time, and so doing something like this where you have a little bit of structure and you have people that know the space that are willing to help you, I would definitely encourage that.
Definitely, and the talk title itself says, blockchain is ready for you. So I'm also looking forward to the same, because I'm personally a newbie and a beginner completely in blockchain space and would love to, leverage this platform at the same time. Cool. I see one more question. What am I supposed to know before starting with blockchain? I guess the answer is same. Let's
answer,
get
yeah.
ready for the Dean's session. So let me quickly invite Dean on the stage as well before we actually start. So here we have.
Hey, Dean.
Hi, Dean. How's it going?
It would help if I didn't mute, wouldn't it? There we go. Hello, everybody. Thank you for having me.
Thanks for joining. Super awesome to have you over here as well. How's it going for you?
It's going really well. It is. We're on the west coast here of US, so it's an early morning. This is a good way to get started. Have all day to hack.
Yeah, definitely. Full of energy. All the excitement in the chat as well, and we are quite looking forward to your stream as well. Cool. So before we actually, I can already see your screen, but let's begin with your introduction, if you'd like to do that first.
Sure. So I'm Dean Tribble. I'm CEO of Agoric. Agoric, the company was founded in 2018 by some pioneers in the space of blockchain. And we're pioneers because we've been working on some of the core ideas for literally decades before. I worked on the first production smart contract back in 1989, and we've been doing large scale distributed systems or large scale secure e-commerce.
Oops.
Looks
like we lost Dean.
Or Roland?
No, I see it too.
Oh, did I cut in and out? Am I back?
You're back.
Can you hear me?
You're back.
Excellent. Hopefully that won't happen very often. We've been building a lot of this technology and for large scale, computer supported cooperation between humans and enabling humans and strangers to do business with each other, and in a wide variety of circumstances. And blockchain is the newest and most powerful tool for enabling rapid development of new interesting businesses. So I'm very excited with the technology and with the industry, and love to share it here with you.
Definitely, and we are also more than excited as well. You can definitely see the chat. People are more than happy to have you over here. They're welcoming and appreciating your time over here. So let's quickly begin. I'll quickly add the screen. Cool. Here we are.
All right. So as I said, I'm Dean Tribble, and the thing that's exciting about being here is that this is a hackathon that is not, oh, here's blockchain, let's just do blockchain. It's all about accomplishing a lot of goals, where this is one of many tools in your arsenal. I'm going to introduce a lot of the basic concepts in blockchain and how to bring things together, leading up towards Kate Sills talking and showing you specifically how to program in detail inside of VS Code and so forth. And this will put in context a bunch of the use case and business ideas that Roland just talked through. So first is, all those things that Roland was showing, the loan contracts, all the interesting DeFi businesses, NFTs, they're smart contracts. And so my first question, and imagine, if you will, an audience out there of all of you raising hands, how many people in the audience, how many of you have used a smart contract, right? And people go, oh, blockchain, never heard of it. Of course I haven't. No. Okay, smart contracts, here's the definition of smart contracts: a contract-like arrangement expressed in code where the execution of the code is enforcing the terms of the contract. So eBay, PayPal, Venmo, Airbnb, Uber, Lyft, much of Amazon, high-frequency trading. Those are all things where software in the middle, hosted by some trusted third party, but software in the middle is orchestrating the relationship between, the rider and the driver, or the bidder and the seller in an auction. And if there are disputes, it's got software to be able to escalate and determine, what's the scope of the dispute and how do we resolve it and all that sort of thing. And so smart contracts were a new class of business that came out in the very early days of the internet that really enabled new classes of cooperation between people. And it's something that is, easily, past trillions of dollars in market cap for smart contract businesses in the world. So this all predates blockchain. What is blockchain, and what does blockchain bring? Right? The gold standard of blockchains is multiple independent computers. So they're in different administrative domains, different companies, different people with access to these machines in different jurisdictions, so that there's no one country or person or company that can sneak in and backdoor it and steal things or change the behavior. Where those different computers all vote in some fashion, come to consensus in some fashion to agree on data. Like Dean has $100 in his money account. The order of events: Dean placed a bid in this auction, and then a little later, the auction is closing, and Dean is trying to revoke his bid and say, no, never mind, I didn't want that. And now either I win the auction or I get my money back, depending on the order of the auction closing or me revoking my bid. That determination has to be agreed on by those several hundred computers in these different jurisdictions. And then finally, the results of computation. Okay, the auction contract actually runs and decides that Dean was the highest bidder, and the auction closed first. And so now Dean is the winner, even though he was trying to welch on his bid. So those results of computation, those computations are the smart contracts. And so what happens when we bring blockchain under the general ability to do smart contracts is we get computing with integrity, right? We get a platform where it's running software that no one on the planet can corrupt the execution of. Now, it's important to note that, I talked about smart contracts that predate blockchain, but with blockchain, Bitcoin is a smart contract, right? It's software that is enforcing the terms of transfer and who's allowed to pick up money. among all of the millions of strangers that are participating in this system. Ethereum added the ability for people to upload their own programs. So now it wasn't just a single smart contract, but it was a set of smart contracts that could work together. But it had a lot of issues, and so there's a lot of reason to build new blockchains out there that have features that make it much easier for mainstream developers that are focused on a vertical to be able to use their current tools to build new smart contracts and to quickly build new applications. And so Agoric is indeed producing a new blockchain where it is programmable in a hardened version of JavaScript. So if you can program Node.js, if you can program React.js, then you can use our framework to be able to program smart contracts, right? If you think of React.js as a user interface framework in JavaScript that makes it very easy to have components for rendering graphics or doing interaction, and makes it very easy to plug them together to be able to build fast some new application. That's a model where it's a framework that is designed to help the creation of user interfaces, the handling of mouse clicks and rendering. We have a similar framework in Spirit where what it helps with is the handling of digital assets. And I'll show some examples of this. It helps with DeFi Legos. So instead of having a component and a button and a mouse event handler, what you have is an auction and a digital asset and a transaction handler. Right? Or, so you have things to help with these transactions. Okay. So let me go back to here. So the kind of environment that people will be building smart contracts, that you will build smart contracts and deploy in, is what we call the Agoric economy or a crypto economy, where it's all up here. There's a whole lot of layers down below, and particular contracts like Roland talked about a loan contract to be able to borrow a stable coin. So you bring in some high value but volatile asset like, in the physical world, it would be gold. In the crypto world, it might be atoms. And you borrow a stable coin, where in the physical world, it might be dollars. Here it's Run is the name of the coin, which is about equal to $1, but it's a digital asset that can transact easily in this computational system. And the smart contract that you'll build during this hackathon, it's the kind of thing that would deploy up here in the smart contract economy to be paid Run, to buy services from other smart contracts using Run, and so forth. And just like the normal economy, there's a whole lot of stuff happening down below the surface of the water to enable the economy to flow forward and to enable payments and money transfers and all those kinds of things to work. That's all part of the underlying staking economy. We're not going to focus on that. So at a technical level, there are several layers of the system, the Agoric stack, if you will, and you're mostly going to be staying up here at the top layer. Most programmers, they want to focus on their application. They're going to build fast stuff build stuff quickly using the framework that makes building of new applications with components easy. Okay, so I'll say just a tiny bit about all these layers so that you can recognize them when you see them, or understand where they fit in the world that you're now building in. So at the bottom layer is that consensus layer, that voting protocol, so that the hundreds of machines in different locations can vote to agree on what happened. That we're building in an ecosystem called Cosmos, using a protocol for agreement called Tendermint. And if you look around, if you took computer science in school, you've heard of Paxos. There's lots of other consensus mechanisms. What blockchain has done is really advance the state of the art in those ways that multiple computers can come to agreement about what happened. And Tendermint is one of the best battle-tested algorithms out there for doing general agreement across a lot of computers. We then build our environment to run the hardened version of JavaScript. So this is JavaScript with the security holes in it locked down so that we can run the same program on hundreds of machines and get the same answer, and no one's in a position to mess it up, right? And so we have our virtual machine for that JavaScript running on top of Cosmos. In that, we have a protocol in this, and by protocol I mean a JavaScript API, right? And so this is like the render and event API in React, or the file API in Node. It is the API for being able to easily create and talk about and exchange digital assets. And then above that, we then have the framework, right? Again, that's like React.js or like Node.js or Vue.js or any of these things. It is the framework where it lets you talk about, okay, here's the function I want to invoke when I get a new offer into my contract. Here's the fee structure I want to charge for the actions that users are taking. And then finally, of course, using that, we have built several smart contracts. Kate will walk you through the creation of a new one, and you will be building smart contracts up here in this user-defined contracts land. Now, one of the important points about that is again, if you're familiar with any of the other blockchain infrastructures out there right now, mostly every new smart contract is starting from scratch, and every new business is a silo. It's like you have to do, your own dishwashing, your own legal, handle all your HR, and manage your own premises when you're a 2-person startup company, right? It doesn't make any sense. Right? So the whole point of Zoe and this framework is exactly that component model that we see in other parts of the JavaScript world. You can take an auction contract, take a loan contract, put them together to build some new environment where you're liquidating loans by auctioning them off. And you can do that without having to build your own auction, because you were able to use that pre-existing contract for auctions that some expert already knew how to build and already built and deployed. Okay. Excuse me. So, let me describe some of those, excuse me, some of those DeFi components. So ERTP, I mentioned ERTP is that layer of just sort of the base layer of digital assets. So I have purses, which hold those, those are like bank accounts, only, they're much more portable. So they're purses, and I can have a purse that holds Run, which is that dollar pegged stable local currency in our environment. I can have a purse that holds digital art from the Guggenheim, right? I can have a purse that holds atoms, that holds ETH, all of these kinds of things. I have payments. So from a purse, I can withdraw a payment in order to send it to you. You then receive the payment and deposit it into your purse, right? And now we've done a transfer. I have a mint, or rather smart contracts that are creating new kinds of tokens, new kinds of digital assets, new kinds of NFTs, non-fungible tokens, etc. They will have a mint with which they exclusively hold the authority to create new instances of that asset. So if someone is releasing a new NFT, they will be able to, stamp it out by calling the mint, and that's just a call in JavaScript that you may see later when we're showing the actual code. And then finally, we have issuers that let you verify that a payment that someone handed you is indeed a payment in the kind of thing that you were looking for, right? Remember, this is all in JavaScript. So if I say, Roland.enjoy open paren, a concert ticket close paren, right? Roland receives a thing that, he thinks is a concert ticket. His enjoy function is invoked with a concert ticket, but it might just be, a random file object or any other JavaScript object. What he can do is take that to the issuer and say, hey, concert venues issuer, is this really a ticket? And the issuer will go, yep, here it is. And now you have exclusive access to it. Nobody else on the planet has it. And now Roland, who has received a payment of a concert ticket that I pulled out of my purse and sent to him, has verified through the issuer that it is indeed the kind of concert ticket that he was expecting, and he has taken possession of it, so he has exclusive access to it. These are some of the core protocol in the electronic rights transfer protocol that lets us easily in JavaScript, in a familiar language with familiar tools, be able to build these new interesting kinds of businesses and build them quickly and put together these components. And so these are all tied together with brands. So, a purse is a purse of atoms, or a purse of art from the Guggenheim, or a purse of concert tickets. And I have a collection of those. Right? and amounts where I can now describe the desired seat that I want, which is seat 34, or I can describe that I want $50 for purchasing seat 34 without having to give you a $50 bill in order to explain it. Right? I can talk about $50. I can say I want $50, and that's what an amount is. And that lets our programs negotiate, talk about pricing and all those kinds of things in a consistent way that's easy to render, easy for users to interact with, and so forth. Okay, and so those are some of the early DeFi Legos. The purchase, payments, and fungible tokens. Those are the basic ones. We then have lots of DeFi Legos, and you will add more. But many of these initial applications that you'll start with are just going to be taking an existing contract or an existing component and just using it as is for a particular business function. So taking an auction and defining your own kind of asset with one line of JavaScript that you're going to auction off. Or taking the atomic swap and arranging to do I'll put up my, rights to a concert ticket. If you put up your rights to that digital asset, okay, we both put them up. It does the swap. Each of us gets what we want. And we do that with only a smart contract in the middle, without having to have, an eBay in the middle that's handling this stuff. Okay, so I'm not going to go through all of these, but the software that you'll see has several of these components available. And so if there's a particular kind of thing that you were looking to do, you can pick one of those and you get to start from there, or glue it together and just parameterize it and glue it together with other components. Okay, I'm not going to show contract code because you're going to see a bunch of that when you dig into programming with Kate. But I will talk, one more set of concepts here. I think I've got 7 minutes left here. In much of blockchain, right? Blockchain is early days. We've got a lot of analogies that really look at it as being in about the place that the internet was in 92, 93 to 94, 1994, in terms of adoption and in terms of use cases, and people starting to go, oh, there's a real thing here. There's actually hundreds of billions of dollars on blockchain systems that people are trading on an ongoing basis. I didn't realize. I should probably go look at that, right? But much of it is very low level. It's very early days, right? And so if I wanted to send my friend Dan Finlay some money, this is actually a picture of the real wallet that is the wallet that 10 million people use on a monthly basis to trade cryptocurrencies. I send it not to Dan Finlay, but to my good friend 0x55 E2, some set of numbers E160, right? I send it to a low-level address, right? That was like in the early days of the internet. I would route email to host IP addresses, or it's like, my characterization is if I was using a spreadsheet, compute a sales number, and now I'm going to tell you where in the memory of the computer to go find the number instead of just showing you on the screen, right? It's crazy, and yet there's hundreds of billions of dollars that happen this way. So it clearly works. But it's, not what my grandma's going to use, right? And this is not just Ethereum. This is, here's the Cosmos one, which similarly, I'm sending money to my good friend Cosmos 1GHK, yeah, whatever, right? And this shows up in applications as well, where I will, Roland showed you Uniswap. You negotiate in this beautiful UI to say, I want to trade this token for that token, or I want to buy that NFT. You push the buy button, and it's going to pop up one of these things to say, oh, okay, did you want to send 30 atoms off to 0x547? I don't know. Maybe, I guess, right? I guess it's 0x54 or something or other, not a reliable way to build things. And so the Agoric platform really takes many, many characteristics, many, many properties to make it easier, to make it safer for clients to interact with smart contracts and to interact with each other. And so, for example, if we had a swap contract, I want to swap, in this case, this is like that Uniswap UI, where I'm going to swap, 3,000 of Moolah for 2,000 of simoleons. Those are just two fake fungible token money types, right? The presentation in the wallet is not send money to a random number. It's actually the offer. It's actually the quid pro quo. You can have this moolah if only you give me this simoleon, right? And the entire infrastructure provides that assurance. And so we have this fundamental notion of offers that will show up in the programming and show up throughout the system, where, if I'm a seller of a concert ticket, I will express in code, I will give you this concert ticket, but what I want is at least 30 moolah, right? Or at least 40 run, right? The currency of that we use inside the Agoric system, right? And the clients, as bidders to this auction smart contract, they're making the same kind of offers where each bid is, I will give you at most Y moolah or run or whatever it is, right? And what I want is a concert ticket, or what I want is a particular concert ticket. Or as you get richer and richer smart contracts, I want 3 concert tickets together that have at least this good a view, right? Whatever the criteria is for my want that I can express in the API that we have in the Zoe, the Zoe smart contract infrastructure, that's what a user can provide, right? And so what that means, so what happens is, instead of the money just going to the smart contract and now you hope it does the right thing, our entire smart contract framework helps it do the right thing. So the money, instead of going to the smart contract itself, it goes into Zoe, and Zoe escrows it and tells the smart contract, hey, I have some money that has been submitted as part of this proposed offer. Are you interested? And now the smart contract collects offers, like it has, like if it's an auction, it's got the offer from the seller to sell something, and it's got a bunch of offers from the bidders, and it goes, okay, it's now time for me to decide. I'm going to look through the offers, and I'm going to decide that guy is the winner. I will reallocate his money to the seller and the seller's concert ticket to that bidder. And now it's done a reallocate. But there's a couple of key constraints in that reallocate. And that reallocate is taking the assets that were escrowed on behalf of all of the participants in the contract to then enable this business to happen. And this is where the magic of Zoe that provides deep protection across the system comes in, is that reallocation must satisfy the constraints on all the offers. And so the seller must get at least X moolah. And the client, in order to give up his Y moolah, must get the concert ticket he's looking for. And so that means that if I've done a swap that makes 2 people happy, it will succeed. And if I have done a swap that does not satisfy the constraints of those offers, it will fail. If I've done a reallocate that does not satisfy all those constraints, it will fail. So what that means is, I'll finish here. And then Zoe provides a payout when the auction is done. I've completed. I tell everyone, okay, we're done. Go away. Then Zoe will give people back either their winnings, so the concert ticket, or a refund, which is the money that they bid but didn't end up spending because they didn't win. Or in the case of the winner, it might be the excess money where they bid more than they actually ended up having to pay. And the nice thing is, you don't have to write all that code because Zoe handles it for you, right? And Zoe handles it correctly for you every time. And so it protects you, it protects your clients from your bugs, and it protects you from screwing up and screwing your clients because you introduced a subtle bug somewhere. What happens is everyone's like, oh, okay, that's not that trade is not going to work out because you're actually trying to give them slightly less than they required. So rather than stiff them, everyone's going to go away. Everyone gets their refund and we'll try again another day. Right. So what that looks like in code, remember, this is JavaScript, is that I can make a proposal. Right. So the proposal is, I want a particular seat and I'm willing to pay 100 run. And exit is in addition to making sure that I get what I want or I get my money back. When I want my money back, by gosh, I get it, and the contract can't get in the way. Turns out there's been literally over $1 billion locked up in Ethereum because smart contracts messed that up, and they ended up sitting on people's money and they can't get their money back. Right? Bad idea. We systemically prevent that. Right? So, and I'll wrap up here in just a minute. And so I have this proposal. I pull from my pile of run, I withdraw the 100 run, and then I make that as an offer through Zoe to the buyer invitation. So the buyer invitation is, in this case, the seat at the auction that says I'm a bidder. I'm a guy in the audience that can raise my paddle and say, yep, I want to bid. So I'm making an offer to buy that concert ticket for that proposal, right? And this is all JavaScript. I get back a promise. I await the payouts from the promise, and the payout either includes my money back or it includes my concert ticket. And Kate will bring you into real code rather than this pseudocode here, and you'll see exactly how this is done. But there's lots of components that just written in JavaScript like this, you're not dealing with crypto. You're not dealing with all these lower level crypto blockchain complexities. You get to really focus on the business logic of what you're trying to accomplish, so you can build an application fast, right? And so we ensure to clients that they get their desired payout or refund regardless of the behavior of the contract, right? A misbehaving contract still cannot take their money unless it gives them what they want. And otherwise they get their money back. And to the contract, it gives you the simple assurances that you can synchronously act on the offers provided. All the assets are available. They match their descriptions. All of the delivery and payouts and everything else will be handled for you. All that kind of stuff that you would like to it's like, running a business where you get to focus on your business, and all the delivery and fulfillment and rent and all that sort of stuff is handled for you, right? And so that's an introduction to key concepts. Kate is going to then show you how to actually make it real inside of building and deploying a smart contract. So I can take some questions, or we can jump straight into coding here.
Awesome, Dean. Thanks a lot for that wonderful presentation. It was lovely getting all those insights and understanding more about the blockchain space altogether. I do see few questions in the chat. Let me quickly bring that up. So there's someone asking, is it necessary to learn JavaScript to start the blockchain development?
So there are different blockchains that have different programming languages. The key is, of course, the reason why we do JavaScript is there are 10 million JavaScript developers out there already. 80% of the developers know JavaScript, and there's lots and lots of training aids and that sort of thing. Most blockchains use custom special languages for those blockchains that tend to be very unfamiliar. And so the biggest smart contract blockchain out there, Ethereum, there's at best 10,000 programmers in the world that can program that stuff. So it is not necessary to learn JavaScript, but that is almost certainly the lowest hanging fruit language to learn to be able to program blockchain.
Awesome. Wonderful. Thanks a lot. One more question from Vidhi. Any project suggestion on blockchain according to you, especially for beginners?
Talk. I mean, the answer is absolutely. The world of NFTs is exploding, and the cool thing about NFTs is, a lot of what they're about, the sort of the autographs for things, autograph for, here I own the digital rights to this image. Am I back? I'm popping in and out. So a big chunk of it, in the NFT world. Good. Am I back? Yeah. Right. So take a look at Kate's thing. The NFT world is exploding, where these NFTs can simply be art, or they can be membership and engagement. And so they tie well with the kind of engagement that people on band sites and sports sites and, memberships and clubs and all those kinds of things do already in JavaScript. Well, now it can grow into having real tradable membership cards and secondary markets for participation. And there's some real low hanging fruit there that it's a really good place to start.
Awesome. Wonderful. One more question from Mahesh. How can we use blockchain in Android development?
So, the big thing, blockchains are, I sometimes refer to this as Node.js for DeFi, right? The blockchains themselves are server side. So there are definitely mobile apps that can, build in whatever you want to build the mobile app in, but then you talk to the blockchain so that if I'm sending you money, or I'm sending you rights to get into this local, Insta rave that we all decided to start in some warehouse, right? Whatever it is, right? That can be done over a mobile application. There are digital wallets on Android, there are digital wallets on iPhone, but the transaction, the server side of it, is this decentralized thing that is not running in one place. It's running on the blockchain.
Awesome. One more question, which says when we should be able to buy BLD tokens on DEX or CEX. I'm not sure how does that pronounce.
So build token is the staking token for the Agoric system. This is the almost always the question of, when buy token. We do intend to have a public sale in the future. We are not, we do not have any details available for it now. So you'll have to watch the Agoric announce channel, or join our Discord and be able to find that out when it happens.
Definitely. I'll also be sharing the Discord link in the chat, so make sure you join over there as well. Cool. What else? We have what's the most popular blockchain?
Well, so since Agoric is just at the beta stage and coming out later this year, it is not yet the most. But just like JavaScript is the most popular programming language, I expect it will be. But right now, by money, it's Bitcoin because it's just for trading money, right? It's just, Bitcoin was the first. It laid the groundwork for this consensus of lots of machines to figure it, to decide what's going on. For existing assets, it's probably Ethereum. But Ethereum has many native security hazards. It's very hard to program, and it's very expensive to operate on. So there's a lot of people moving away from it to other blockchains. And so, that's where, we expect that a big chunk of the future moves on to the Agoric chain, simply because of the programmability, right? The hard thing to scale. There's a lot, blockchain is new and there's a lot of scaling happening. How do I get more transactions? How do I get faster throughput? How do I make it cheaper? But the hardest thing to scale is you guys, right? The hardest thing to scale is programmability, is being able to have more people able to solve more problems. That's the hardest thing to scale. That's the big win for JavaScript, is enabling more people to be able to access this stuff. And that's our mission.
Awesome, wonderful. And very interesting question coming in. Can a blockchain be hacked?
Well, yes, everything can be hacked. The question is, can it be hacked successfully? so there's levels at which probably not very likely, because it's just been, these things have been pretty well battle tested. And there are areas of which we know it gets hacked. They get hacked all the time. Now, especially on systems like Ethereum, there are native security hazards in the programming model, right? Reentrancy attacks are something that one of our lead engineer, in the security review of Ethereum before it came out and got big, pointed out that there would be a reentrancy attack where, contract A calls contract B, and contract B sneaks in and calls A in order to steal some money before it returns. And people literally lost, billions of dollars to reentrancy attacks where we identified that there would be that issue early on. It's simplifying. It makes it a little easier to do toy examples, but it means that you hit the wall from the ability, in terms of the ability to write complex systems. And so indeed, there was a reentrancy attack, 3 weeks ago, where someone took $660 million. Now, much of that has been returned because they were able to trace it down and block the exits and that sort of thing. But that was a class where the security hazards of programming in the Ethereum model in particular led to that exposure. Many of the elements of the Agoric system design are sort of informed by our long history of doing blockchain, and also by seeing what are the kinds of issues that people stumble into, and making sure that those are that those are protected. But it's always a challenge, and this is something where, just like any computer system, it's critical to be as vigilant as possible with respect to security. And the other thing we're working on is making it so that you can get cyber insurance with respect to execution of contracts on our system. But we'll talk more about that once we launch.
Awesome. Thanks a lot for all of those wonderful insight, giving such a great answer to that question. Thanks a lot for doing that. And I see a question for which the answer lies in the next upcoming session by Kate herself. So people want to know how can they create their own NFT. So stay tuned. Let me quickly bring up Kate on the screen.
The way I would create my own NFT is I would ask Kate to build something, because she's like put stuff out like this. So
definitely quite looking forward to the same as well. You all will learn how to build your own NFT application. So stay tuned and get hyped once again, just like the way you are doing in the chat. Thanks a lot. And thanks a lot, Dean, for that wonderful introduction of blockchain and everything you shared about Agoric around the same as well. Thanks a lot for that.
Well, thank you for having me, and I look forward to watching the next doc.
Definitely. Thanks a lot. Cool, Kate. So let's start with your brief introduction so that our audience can know more about you, and then I'll quickly bring up your screen.
Sure. So thank you so much for having me. So my name is Kate Sills. I'm a software engineer here at Agoric, and I'm the engineering lead on our smart contract framework, which is Zoe.
Awesome. Wonderful. Thanks a lot, Kate. So here are your slides, and let's start.
All right, yeah, let's get started. So thank you so much, Aditya, for that question. It really leads really well into this. So today we're going to be learning about how to quickly build an NFT application. And specifically, we're going to be learning how to build an NFT drop contract. And so what does this mean? So this means that users are going to be able to buy NFTs with money. The NFTs are going to be minted on demand. The users won't know exactly what they bought until later. And then some NFTs are going to be more rare and valuable than others. So if we have some time, we'll build out some extra features. So rather than just minting one NFT, we'll mint multiple NFTs at once. Potentially, we could cap the number of NFTs minted total and for any one transaction. We might want to add something like a start time before which minting cannot occur. And we might want to have a credible reveal of metadata using a hash contributed earlier. So just to explain a little bit more about this, oftentimes you want to have metadata that's associated with the NFT, but you don't want it to be known at the time that people are buying the NFTs or the NFTs are being minted, because that might incentivize them to buy certain NFTs and not others. So part of the game of the smart contract is that people are only going to find out later. And so, but in order for that to be credible, so that I'm not able to pick and choose who has a rare and valuable NFT out of the ones that are already owned, I need some way of revealing the data later in a way that people can link back to what was already done earlier. So using a cryptographic hash and putting that in the smart contract and then allowing users to match that to the actual metadata later is the way that you can do that. And then lastly, of course, we want to be able to collect our earnings from this contract. And so I have a whole bunch of rocks here on the screen because I thought it would be fun if the theme of this contract is kind of a pet rock type contract where the NFTs are actually different types of rocks. And but maybe they're geodes or something, and we don't know what they're actually made of yet. So maybe some of them have gold inside, maybe some of them are really plain. We don't know. So that's kind of the fun concepts that we're playing with here. All right, so the prerequisites. So if you are watching this live and you don't have your environment set up, don't worry about it. We'll be able to go back and you can set that up. But if you are not watching this live, if you're watching a recording, feel free to pause the video here, go to agoric.com documentation, and get set up, follow the instructions there, and then come back. But the prerequisites that you're going to need, so I'm going to be building with node 14. I'm also going to be using Yarn 1, so not Yarn 2. And I'm going to be using the Agoric SDK repository for all of the Agoric libraries. And then lastly, I'm going to be using Ava, which is a testing framework for testing. So first let's start with the basics. So we're going to set up our tests. We're going to install the code for the smart contract. We're going to start an instance, and then we're going to make an offer. And in that offer, we're going to pay the money, and then we're going to get an NFT. All right, so let's actually transition to the code. So I'm going to start with the tests. So I've put in a lot of the imports that we're going to need. And if you're not familiar with JavaScript, feel free to just kind of let this wash over you. But if you are familiar, you're going to see some really common things here. So we use the ECMAScript imports, and so we don't use the common JS format. And this is an Ava test. So we can run that by doing yarn test, watch. And just to give some background, this is the kind of thing that you'll see if you started through the documentation. This is the format of ADAPT. I've deleted the UI and I've deleted the API folders because we're not going to be using those today. We're using the contracts. So let's see. So we are starting with, in the contract folder, there's a source directory. That's going to be where our contract code goes. And there is a test directory. So what I'm going to do is yarn test watch. And what this will do is it'll continuously run the tests, and then we'll be able to see whether the tests are passing or not. Oh, let's see. I will try to increase the font size. Can everyone see that? All right. I'm going to assume that that's okay. Okay, so we can see here that we ran the tests, and it says the test finished, and there were not any assertions. Okay, so that's expected because this is completely blank. So let's actually change that to be t true, and let's pass in true just to see what that looks like. All right, so our test passed. It was pretty trivial, but it passed, right? Okay, so let's first start with making some imaginary tokens that we're going to be using for money. So let's put that in. And let's explain a little bit. I know if you've watched our previous sessions, Dean has talked about this a little bit, but ERTP is our token standard, and that's how we can create fungible and non-fungible tokens. So for the purposes of this test, we're going to be using ERTP. We import the make issuer kit, and let's just give it the name money. And in here, we're going to be using the defaults. So by default, this is going to be a fungible token. By default, the decimal places are going to be 0. So we're just using all of the defaults here. And when we call make issuer kit, we get an issuer, a brand, and a mint. So let's rename those with money issuer, money brand, and money mint. Okay. So the next thing that we're going to want to do is set up Zoe for the tests. Now this is something that you're only going to need to do for the tests themselves. You're not going to need to do this on the actual chain because there will be a Zoe that actually exists. So I'm just going to paste this in here, but I'm not going to go into detail explaining it. Effectively, what we're doing is we're making a Zoe service, we are making a fee purse, and then we are going to be using that fee purse with Zoe so that we can pay for execution and pay for any kind of fees that are being charged. But the important part for our test is that now we have Zoe here. And Zoe is the smart contract framework that we're going to be calling a lot of different methods on. One thing that I should explain, though, is this E here. So this E stands for eventual send. And that's how we are able to call methods on objects that may be, if we're off-chain, they're on-chain objects, or vice versa. And so it allows us to call methods on objects that are remote. Which is something that is really unique to Agoric, is that you have the same development environment no matter where you are or no matter where the objects live. So that's something that's very unique to Agoric, but when you see this E, that means that we are making a call on an object that may be remote. All right, so we have a lot to get through, so I'll start going a little bit faster, I think. All right, so we want to first bundle or pack the contract. This is just taking the contract path. So it's this NFT drop contract. Let's go there. Right now, this is pretty much empty, but this is the particular format that you're going to see for a contract. Right now, we're taking that and we are going to bundle it. And then let's actually install the code on Zoe. So we just call Zoe install, and you can see the E that we saw earlier. And that creates an installation. All right, so an installation is basically a unique identifier that says that this code has been installed on Zoe, and you can reference it. And so we can use that installation to actually create a running instance of the contract. So let's do that. So the way that we do that is we call Zoe start instance, but we're going to need to pass in a few things. So the first thing that we pass in is the installation itself. That explains what code to use. We're also going to need to pass in any issuers that we want to use in the contract, as well as the terms. So the issuers are going to be, we're going to use our money issuer that we defined up here. And our terms are going to be, we're going to need a price per NFT, and we're going to need an NFT name, which let's say it's Pet Rocks, right? So these are our rocks that people are going to buy, and maybe some of them are going to be valuable, but others are just going to be rocks that are great as pets. I don't know. So let's define actually that price per NFT. Let's say that it is 10 money. All right. So we still have no assertions, but let's go further and let's actually try to make an offer. So let's do this. All right, so when we're making an offer, we're going to need a few things. So we need to go a little bit faster, so I pasted a ton of code in here. Feel free to come back later to look at this in more detail. But we're going to use the instance to get a public facet. We're going to use the public facet to make an invitation. And invitations are how you access all of the contracts on Agoric. You have to be invited to the contract. So this is something that's very different than Ethereum, where anyone can call any contract at any time. All right, and we are going to make our offer. So we need that invitation that I mentioned. We're also going to need to make a proposal, as well as send payments in for the actual assets that Zoe is going to escrow. All right, so we, in our proposal, we are going to give the money. And remember, we said that the price per NFT was going to be 10. So let's give at least 10 and then a little extra, just to make sure that we can test the refund path. So we're going to give 11. So let's see. So we are also going to specify our want. So this is something that's very important for enforcing what we call offer safety. So offer safety means that you're guaranteed to get what you gave, or you're guaranteed to get what you wanted, or both. And so this protects you from malicious or buggy contracts as a user. So we're going to say we're going to want some NFTs. It's going to be the NFT brand that the contract is going to make, and we want the first NFT. So that's an NFT with the ID 1. And if you see numbers that have a suffix of n, that means that they're a big int. Big ints are the safer version of integers. They don't have any kind of ceiling like integers do. So some integers are unsafe. They wrap around and it's actually not safe. Big ints, you can go as big as you want, and it's perfectly safe. So we're going to be using big ints for most of the time. All right, so we make our payments, or we use the money mint that we defined up here, and we're minting 11. That's a little extra. That's the price per NFT plus 1, and we make our offer. So we can see here that we have some errors. We have some errors because we haven't defined anything in the contract yet. So let's go ahead and do that. So let me bring that up. So we have our contract code here. I've imported some things, but it's pretty empty. So let's start by getting the terms. So the terms of the contract, this is what we passed in, and this is how we access it in the contract code itself. All right. So in a real life scenario, you are really going to want to do some input validation on these terms. You're going to want to check that this is an amount and that this is a string. And I would love to show how to do that, but we are running out of time. So I'm going to skip that for now. But let's go ahead and make the mint here. So we are going to use this NFT name. So it's going to be Pet Rocks. And unlike the mint that we made earlier for the fake money token, this is going to be an assetkinds.set, which means it's a non-fungible token. And we have a lot more documentation on this. I'm going through this very quickly, but you can check out our ERTP guide and our Zoe guide for more information about how to mint tokens within a contract. All right, so we are going to get the NFT brand from there as well. Okay, so let's see. So let's go down here. Okay, so we still have no assertions, but we didn't have any errors, so that's good. All right. So let's go back to our contract, and let's go up here and actually make sure that this is an invitation. So let's see, if we go Zoe, get invitation issuer. And let's see, let's use the invitation issuer to get the amount of the invitation. Let's see, invitation amount. And let's see if we can test what this is. Let's test the value. All right, so it said target has no invitation, has no make invitation. So let's go ahead and fix that. So what we're going to be doing is we're going to be adding a public facet that has the ability to make an invitation. So all of the Zoe contracts, the way that either the creator of the contract can access it or the public is by returning an object that gives access. So in this case, we're going to add a public facet that has a method make invitation, and that links to a method called buy NFTs. All right, so let's see what has happened. All right. So make invitation now works, but buy NFTs is not defined. All right, so let's go ahead and define that. I'm gonna try to speed up here because I know we are running out of time. All right, so this is a very simplistic version, but buy NFTs is what we call an offer handler. And what that means is that when an invitation is redeemed, this is what we're gonna get. So first we're gonna need to mint the NFTs. So that takes the NFT brand. It'll also take a current ID. So let's add that in. Let's say that our current ID is 1. Let's start there, and then we'll increment that. So the way that we can mint these NFTs is by using mint.mintgains and then applying them to the buyer seat. The way to think about a seat is that it's an offer that's in progress that the contract is able to reallocate things to or take things from. So in this case, we are going to take the money from the buyer seat and then give it to the seller seat. So we need to create that seller seat. And effectively what that is it's representing the interests of the creator of the contract. So this is going to be where we collect all of the money that comes from the NFT sale. All right, so we take that money, we take it off the buyer seat, we put it on the seller seat, and then we reallocate between the buyer and the seller seat. And then we exit the seller seat. So going back to our test, let's go ahead and test a few other things. So I'm going to be, let's get rid of this part. We don't need that anymore. And I'm going to be tossing a lot of code in here for the sake of time, but we should be able to see that we made an offer. Let's scroll down here. Awesome, it passed. Okay, so we made an offer. We got a seat back. We can get the offer result, and the offer result is just what was returned here. Basically, the contract can return whatever it wants. This could be an object that allows for further actions in the contract that are private, that are only accessible to the person that made this offer. But we can see that we got the offer result that we expected. And we also got a payout. We got a payout of NFTs in the form of an ERTP payment, and we got a payout of money. And then we used the issuers to get the amount of that. So part of the design of ERTP and Zoe is that when someone sends you something, you don't necessarily trust it, right? But you do trust the issuers for different assets. So we always have to ask the issuer what the balance of something is or what the amount of something is. So we got the money amount and the NFT amount. We can see that the NFT amount was an NFT that has the first ID, right? It's just 1. And we can see that we got a refund of 1 money. So I think I am out of time, but this is the very basic version of an NFT drop contract. And if you're interested, we'll give more documentation on how to actually add the extra features that that I talked about. So for instance, minting multiple NFTs at once, capping the number of NFTs, having a start time before which minting cannot occur, and a credible reveal of metadata using the hash contributed earlier, and most importantly, collecting our winnings. So I think that's all the time that we have for now, but I'm open to questions, and I hope this gets you started thinking about NFTs, all the kinds of NFTs that you might be able to build. I think there's a lot of really cool concepts out there, and we would love to help you guys get started. So thank you so much.
Awesome, wonderful, Kate. Thanks a lot for that, insightful presentation and walkthrough entirely to how we can build an NFT application as well at the same time. And I see many of the hackers in the chat had this thing up in their mind. They were very curious that how we can build that. So now you all have this particular presentation. Feel free to go through this live stream. Of course, this will be recorded and staying on our YouTube channel. So feel free to visit it once again, take it out on your own pace, maybe pause it sometime, and just head over to all the links which were mentioned in the chat as well. For example, documentation and anything else which you require. Just in case you're stuck somewhere, you also know where to head to. We have Agoric booth channel specifically in our Discord. So if you have any questions around something, if you are stuck somewhere, or if you have any query around the Agoric itself, or you're stuck somewhere around the code, feel free to tag anyone from the Agoric team, and they'll be more than happy to help you as well. Cool. Let me see if there are any questions from the chat. I do see one from Aditya. He's asking that is Zoe stable enough to use it for production? As Aditya checked the documentation, it's saying that it's still in beta stage.
Yeah, that's a really great question. So we are still in the rapid iteration phase. We're still actively testing things. We're still actively trying to make sure that Zoe is as usable as possible for all of you folks out there. And so we have a staging testnet that we have put up, and we also have a testnet as well. And so Zoe has been put on those testnets, but we do not have any mainnet or anything like that that has Zoe yet. So we are still a ways out from that. That'll be coming up soon though. But the important thing to note is that we are still in the rapid iteration phase. So in the next few months, you may see some changes to Zoe. We'll try to help people as much as possible when it comes to upgrading their contracts to fit whatever changes we make. But we are actively testing and trying to improve it. So it's still in the beta stage.
Definitely. And again, if you want to build something, feel free to do it as well. And you can anytime, reach out to Agoric for any help, and maybe they can deploy it later in the future as well. Awesome. Any other questions in the chat? Feel free to ask anything around NFT. If you have any specific question up there in your mind, this is your chance. Feel free to ask anything. And also, stay tuned for all of those who joined recently. Thanks a lot for joining in. Stay tuned as we are going to announce Agoric Challenge super soon. So it is definitely going to be a lot of fun to build something around the same, and get exposed to all of these technologies at the same time. And Hackathon is a great place to do that. So stay tuned for all of those updates which are going to come up very soon. Cool. Let's see. All right. I see one more question. What are the benefits of using Zoe? Is it Zoe or Zoe? I'm not sure if I'm pronouncing it correctly. Correct me if I'm wrong.
Yeah, it's Zoe. So I think you're right.
Zoe.
So there are a lot of benefits. The first is, so Zoe handles all of the escrowing of assets. And that's great for both users and contract developers. For users, it means that you don't have to trust a smart contract to correctly hold your assets. And if that contract is buggy or malicious and it's holding your assets, it might actually run away with the assets, or it might get locked in the contract or something like that, right? So Zoe guarantees that a buggy or malicious contract can't hold on to your assets. For contract developers, and as a developer myself, I find this very helpful. It kind of provides a safety net, because it means that even if your contract is buggy, even if something wrong happens, at least your users won't be really mad at you, right? Because they'll at least get back what they put in, at the very least. And and they may even get what they wanted. So Zoe helps contract developers a lot in terms of the safety properties that it gives, kind of that's the extra safety net. But there's a lot of other things as well. So we have a number of contract helpers and different components that you can use. You can reuse the contracts that we've already built. So when I was talking about contract installations versus contract instances, like the running version of the contracts, what you can do is take the installations that are already installed on Zoe, so the code that's already installed, and make new instances of that. And that's really great, because if, let's say you're an up-and-coming contract developer or business person, and you want to launch something, but people may not trust you yet because you're new. Well, you can use one of these tried and true contracts, and they will trust that because they've seen it before, and they can look at the installation and know, just by looking at the object using JavaScript object identity, to know that this is something that they've seen before. So that's really fantastic. So rather than like copying and pasting code, you can just rely on the contract installations that already exist.
Definitely. Thanks a lot for that wonderful answer to that. And also, I do have one more interesting question from mine, which I was very curious to ask. For someone, beginner, just like me, if I want to start with NFT, of course, there were some great tips which were shared earlier. But what are your go-to recommendations or suggestions for every beginner out there that they should keep in mind? Or maybe not just that. Many a times we should learn from mistakes. So what is that mistake which a beginner should avoid?
Oh, that's a great question. I would say one mistake that people may make is that they should probably keep in mind is thinking about the usability of their NFT. So this is not necessarily a technical thing to think about, but just kind of thinking about what is the use case for your NFT, right? Is it going to be something that's long lasting, or is it going to be something that's kind of a fad where you're going to lose your community in 2 weeks? So I think really thinking through the interesting use cases for your NFT and how you might be able to add new features or add excitement after the fact, I think is something that would be great to think through. And we would love to really hear about your ideas, especially with the hackathon and the challenges that we're gonna be helping you with.
Absolutely. Thanks a lot for answering that. Awesome. So as of now, I do not see any further questions from the chat. Thanks a lot, everyone, for joining in. Appreciate everyone's engagement in the chat as well. At the same time, you have been a wonderful audience for this live stream. Thanks a lot for everything. And on top of that, thanks a lot, Kate, Dean, Roland, everyone who joined us and made this stream super insightful and knowledgeable at the same time. We definitely look forward to check out Agoric in our coming days. We still have more than one month to go for hackathon, so a lot of time to explore, a lot of time to get started and try out different things altogether. So make sure you make a count of this time. And thanks a lot, Kate, for joining us. It was super fun to have you over here in this live stream.
Thank you so much. And I should probably mention that we have a mainnet rollout schedule on our website, and we'll have more details soon before the start of the hackathon. So if people are interested in our mainnet, that's the place to look.
Awesome, wonderful. We all would definitely be looking forward to that. Cool. Then thanks a lot, Kate. I'll be moving you backstage and we'll be concluding this session. Thanks everyone for joining in. As always, it has been a wonderful stream altogether from our title sponsor, Agoric. And we had different things to learn from this live stream. Of course, you can, get back to the stream. It has been recorded and will be staying on our YouTube channel forever. We learned about decentralized finance, blockchain, NFT, and many more things around Agoric as well at the same time. Make sure you check out the website. I've already shared the Discord link in the chat. We'll also be sharing all the updates about Agoric, about everything related to the challenge, the prizes, and anything which you want to know or should know in the Agoric booth channel on our Discord. So make sure to keep an eye on that particular channel. Other than that, thanks a lot, everyone. I see still there are so many people in the chat. I have promised everyone that we'll be doing a swag giveaway in every stream. So let me quickly bring up the winner for this particular live stream giveaway winner. Without wasting much of your time, the winner from this particular live stream is Aditya Chaudhary. Aditya, thanks a lot for being a wonderful hacker out there in the audience. Really appreciate your presence. All the questions you asked, it was adding a lot of value, not just to hack this fall, but all the audience who have watched us. So wonderful to have you. Make sure to DM me on Discord so that I can guide you with further instruction. And everyone, make sure you have registered for Hack This Fall by visiting the line, website which is going down below. And if you haven't joined our Discord yet, make sure you join us on our Discord. We do have some amazing things coming up every Wednesday. We do HTF Connects at 9 p.m. IST to just connect with our community and hang out, have fun, share ideas, learn from each other, network with each other, and many more things altogether. If you're a swag lover just like me, make sure you head over to our swag page and grab some of the amazing swags we have over there so that you can also flex more about the same as well. We haven't stopped over here. We do have many speaker sessions coming up, so make sure you check out our schedule on our website so that you can be updated about each and everything as well. Last but not the least, I'll quickly share the feedback form link, which can fill, and you'll be able to earn all your certificates from this particular live stream as well. So that was pretty much from my end. Thanks everyone for joining in. All the required links are there in the description. Make sure you check them out as well. And I'll take a leave from now. It was wonderful live stream. Thanks everyone for joining in. And bye bye.